Hello, everybody, and thank you for joining us for the Data Architecture Virtual Group for September 2020. I'm glad everybody could make it today. Today, I'm really happy to have Ike Ellis back for data modeling and with data lakes and Power BI. Really looking forward to this one. My name is Kenny Neal. I'm the co-leader of this chapter along with my partner, Rob Canzaneri. I'm really happy to have everybody here. Some upcoming webinars for us. We do have a sponsored session next month on the 14th with HVR. I'm pretty sure they're still saying that Mark Vandeweil is going to be their speaker, but I don't have a title yet. As soon as I get that, I'll pass it along. And then Alan White will be here in December to talk about performance baselining with PowerShell. If you haven't seen that one before, it's pretty neat. So you can see more information about that and anything else that we get scheduled at dataarc.pass.org. Also, we're always looking for speakers. If you're interested in speaking to our group, you can email us there, dataarchitecture@pass.org, and we'll be happy to work with you and get something on the schedule. As I mentioned, HVR is our continuing sponsor. We're really happy to have them. Thank them for their support, and please check them out at hvr-software.com. Pass Pro is live. If you haven't heard of that, it's a new paid offering from Pass that gets you some discounts and some exclusive training opportunities. Check out that URL down there to learn more information. Virtual Summit is coming up pretty soon with a new wit and diversity keynotes. Use the link there to sign up. Look forward to seeing everybody there. I know I'm going to be signed up and all ready to go. Speaking of, the first 1,500 registrants for Virtual Summit 2020 are going to get a free Bob Ward ebook, which is really nice, and really glad that's something they were able to do. You can still submit a nomination for the Outstanding Volunteer Award. And here are some upcoming virtual group meetings for the other virtual groups coming up later in September. And some upcoming virtual SQL Saturdays for the next few weeks. And check out the other virtual groups. And that is all I've got. So without further ado, I'm going to pass it over to Ike. There you go.
All right. So I'm hoping that just shared with you my PowerPoint presentation. Can you guys see that okay?
I saw it for a brief second and then my screen went blank, but I think that's me. There we go. Yep, looks good.
Got it? Okay, great. So we're going to talk about data modeling trends for analytics, and we're going to talk about how we should create data lakes and data marts that will support Power BI. And some things that people are thinking about in the world of data modeling right now. My name is Ike Ellis, and I'm the general manager for the data and AI practice for Soliance. If you go to ikeellis.com, you can find my Twitter and the YouTube channel I make videos for. I speak a lot at different conferences, and I've written a couple of books, including one called Developing Azure Solutions, which is in the 2nd edition. Let's talk about the state of modeling data for analytics real quick. So our agenda, we're going to talk about where we are today. We'll talk about physical and logical data storage design. We'll also talk about where we're headed with data lakes and Lambda architectures and IoT. We'll talk about some challenges we face with modeling data for the business and challenges with the cloud, and then we'll talk about positioning our solutions with the business. So this might seem a little bit disjointed. A lot of these things are just kind of my random thoughts around data, but I promise you by the end of it, you're going to see the full story. So if you stick with me for the full hour, you'll see where I was headed and why I think that my message is pretty important. Why do we build systems for analytics? We build for all kinds of reasons. We build because we want to make data alerting systems like, hey, collect all of our data so that if we see any fraud, we can get notified that there was fraud. Or if we see like maybe from our order system, we're taking a lot of orders for something, we want to know when our inventory system tells us we're low on that thing that we're making sales on, right? To do that would require us to gather all that data into one place so that we can do reporting and analytics on it so that we can detect when we have something seriously wrong with our business, right? So we're trying to alert for things like that. We do it because we're trying to report to Wall Street or to auditors or compliance officers. We're trying to say, hey, we know the state of our full business, and we have one place where you can look at the state also. We do it for decision support so that leaders can take a look at the way the business is functioning, determine if it's healthy, and determine what changes need to be made and how. We do it for tactical reporting, like if I am running a sales floor and I want to know who my best sales guy is, or things like that. If I'm running a bank, I want to know who my best loan officers are, right? We do it as a platform for machine learning. We do it so that data scientists have a place where they can gather the data, prep it in the way that they want, and then create things that are useful for the business. Things like maybe they want to content tag some of our pictures, or they want to do analytics, text-based analytics on a bunch of resumes that we're getting to make hiring more efficient. Things like that that might require some data analysis and machine learning. We do it for data lineage. For instance, if I'm an organization that takes in data feeds from other places, like let's say that I'm an insurance company and I'm getting data feeds from hospitals, and a hospital says, we're not taking your insurance anymore, delete all of our data. You would need something like data lineage to figure out where that data came from, where it went to, and what to delete in order to be in compliance with that hospital's request. And increasingly, the penalties for being out of compliance can be pretty financially severe, right? We do it for data governance. Is that data good? Are we structuring this data correctly? Are we cleaning it correctly? Are we interpreting it correctly? Where is it going? Things like that. Can you guys hear me okay?
Yeah, you sound good to me.
Okay, great. We do it for data brokerage. Data brokerage is if I've got 15 applications, let's say one application does inventory management, but that inventory management application is interested in the sales of another application, it can go and request the data from that application directly. But if you allow applications to request data from each other directly, you get a spider web of dependencies, meaning data just starts flowing from app to app to app to app, and it becomes increasingly difficult to figure out what the system of record is and who's true. Meaning, if I see an employee list in my inventory app, I can look at the employee list and say, where'd that come from? Did that come from HR, or did that come from some other app that it just pulled data from? That spider web of dependencies is not a great thing. So we create analytic platforms to bring in all the data into a central place and then broker that data to all the other applications so that it kind of goes out, right? And then we do it for historical data archiving, litigation support, things like that. And for decades, this is the way that we created that platform that I just described. The platform that does all of these things, we would create something like this, where we would grab our app data, we would ETL it into a staging environment, then ETL it into an ODS. ODS is operational data store. And then we would create a star schema and a data warehouse, and we might cube it up, or we might or put it in Power BI. So for a long time, we would create these kind of ETL infrastructures where data would just move from left over to the right, and you would see data get cleaner and cleaner and cleaner as it moved to the right, and then would get consumed at the far right. So I built plenty of these systems. I don't know if you guys built these systems. But just to talk real quickly about it, staging, we staged the data so that we didn't have to reload the data if ETL ever failed, right? So we usually kept like 90 days of data in stage. The ODS was often that data brokerage that we talked about earlier. So we would take the relational data, 300 tables, 500 tables, we put it in a great big ODS, and it would look relational. So if there were 500 tables in the source systems, there'd be 500 tables in the ODS, right? It wouldn't be cleaned that well, but it would be in one place, and that one place would allow us to like join data from multiple tables all in one database. And then eventually it would hit a data warehouse or a data mart, where we likely use Kimball dimensional modeling to create a star schema. And a star schema is comprised of facts. So a fact is usually a number, and then dimensions, and dimensions are things that we want to look at that number through, right? So for instance, if you look at this very simple star schema, you'll see that I have a revenue number there. So facts are typically numbers. They're either keys or they're dates, or they're numbers like quantity or revenue or cost or profit. And then if I wanted to see profit by month, right, that by month would be the dimension. So dim date would have by month, by year, by quarter, right? Or if I wanted to see revenue by salesperson, right? You can see at the top of the star schema, there's the salesperson dimension. And I could see things like their name or the store they're based out of or the region or city that they live in, right? So if I wanted to see profit by store city, I could see that there, right? So that's a very easy star schema, but you know what? Star schemas probably shouldn't be that complicated. The simpler they are, the more they'll be used. And then when we create dimension tables, we typically put the text that we want on our reports in the dimension tables. So city, name, region, month name, things like that, those would all go into a dimension table. And fact tables, like I said, are metrics and number-based. One of the increasingly most important thing that we can do with the fact table is specify our grain. For instance, if I'm taking in orders for Walmart, let's say, Walmart has thousands of stores and they make millions of transactions a day, right? And they can have billions of transactions a year. Well, do I want my data mart to have the individual transaction? That might be too much. What I might want to do is summarize those transactions to see maybe their daily total so that I know this store did this daily total, and that's what I'm going to drill down into. Picking the right grain allows us to control the size of the fact table, and it allows us to control the accuracy of the report, meaning we would say to the users, you can drill down to the day level by store, but if you want the transaction level, it's too many. You can't go down that far, right? Choosing the grain appropriately will increase the speed of our ability to ingest data into the data mart or data warehouse and that particular fact table. And it will dictate the size of it and the size of the entire data mart, right? So that's why grain is so important to choose correctly. So there's a lot of reasons to make a star schema. Easy to understand, you have one version of the truth. It's easy to create aggregations by doing a single pass over the data. You get much smaller table counts, which means that's why it's easier to use, because instead of the 300 tables you get in source systems, we get like 12 tables in the star schema. You get faster queries. It's a good place to feed cubes or Power BI data models and share data sets. It's supported by a lot of different BI tools like Excel, Power BI, Tableau, a bunch of others. And this is an important thing I want you to remember. How many minutes am I in? 8 minutes into the presentation, and this is what I want you to remember. If you remember nothing else that I've said today, I want you to remember this. When doing an analytics system, you have two choices. You can either start out by making a star schema, or you can one day wish you did. Those are the two choices. And this is why I'm saying that, because the vendors out there, and I won't name them, Snowflake, but the vendors out there will say, you don't need to make a star schema anymore. In fact, I've heard many people implement column store databases say, you don't need to make star schemas anymore because you can put indexing over like a third normal form database, and it will perform fast enough. It'll be fast enough, so don't worry about it. But speed is not the main reason why we make star schemas. It's the simplicity, the ease of navigation, and the ease of creating reporting artifacts over it. That's why we create star schemas. So one of the main motivations I had for creating this talk was that I wanted to calm some of the noise that I've been hearing from different vendors saying that the era of star schema is over. It is not over. We are neck deep in it. And you can build star schemas in data lakes and be very, very successful. In fact, you should build star schemas in data lakes. Or you should create a different serving layer with star schemas there, but we should not ignore them. Does that make sense? Are we all going to remember that? I hope so. It's hard when I'm giving webinars to get interactivity, but I hope I've made my point.
You got it, Mike.
Okay, good. So you can also create Snowflake schemas, although I think you're just fooling yourself. Let's stick to star schemas. We can simplify your problem to a star schema, even at the cost of data repetition. In fact, data lakes make that cheaper to make large star schemas, and we have fewer excuses to go to a snowflake schema where dimensions relate to other dimensions, which we're trying to avoid. It's okay to duplicate data in data lake. It's cheap and fast, okay? So we can duplicate data. So going back to this enterprise data architecture, which I built and you built, and a lot of us probably have right now, and probably a lot of us are supporting right now, there are a lot of weaknesses with this, and I just want to cover one main weakness. If we had this system and we asked to add a single column, meaning a source system had one column that it wanted to bring all the way through to a Power BI report, and we were using something like this, we would have to add that column 1, 2, 3, 4, 5, 6, 7, 8, 9 places in order to get that column all the way through the artifact, the reporting artifact. And that is not fun. And it takes a long time, and ETL is increasingly fragile. And so when we would change it, things would break. And so we were reluctant to change it, particularly 9 different changes for one column. And so I don't know if I adequately described the pain that sometimes you felt in supporting a system like this, but I have seen many of you at consulting engagements say, you know what, we don't need all of that. I'm just going to go direct to the source, bring the source into Power BI, and then build my data set in Power BI and ignore building an enterprise data architecture. I've seen this happen at several customers. I'm not saying you do it, but I've definitely seen it happen. And I understand it, by the way. I understand why you're doing it. You're doing it because this pain was too severe and you're trying to avoid that pain. But what happens when you do this is you end up creating a whole bunch of data sets with spread out business logic, and you bring a whole bunch of tables into Power BI, and those tables are super slow, and you're repeatedly cleaning the exact same data over and over again. And by the way, I've seen some of these data models, and they aren't pretty. Lots of tables, hard to use, hard to build reports off of. So we would like to avoid that knee-jerk reaction of avoiding an enterprise data architecture if we could. Here's another weakness. SQL Server, and by the way, I'm a strong SQL Server advocate. I've used SQL Server in a lot of places. I think SQL is a great product, but it was overused in data, severely overused. It's not a great place for staging an ODS specifically. One of the reasons why it's not great is SQL Server writes data multiple times on an insert. It writes data for the log, it writes data to the MDF, and it writes data to maintain indexing. So it could write, you could change something or add records, and you could be adding records 5, 10, 15 times before you get an acknowledgement that says that update actually occurred, which is not super efficient. SQL is strongly consistent. The write isn't successful until all the tables and indexes get updated. So if you have triggers, all the triggers have to fire before the write is over. And then finally, SQL is expensive. You get charged based on the amount of cores that you use. That's how SQL licensing works. So if you have 20 terabytes, you're going to need a lot of cores and a lot of memory, and you're going to get charged every time you scale that out or scale that up, okay? So SQL is not that great. So when we look back at this, staging SQL, ODS SQL, data warehouse SQL, and then to Power BI, that's a lot of money that we're talking about, and it's a lot of consistency that we're talking about as we move to left to right? Okay. Weakness number 3, great big data warehouses are very difficult to change and maintain. All the tables need to be consistent with one another, historical data. What often happens is we create these big data warehouses, and over time, we get more data and more data and more data and more data. And when we say, hey, let's delete some of this, they say, oh, you can't delete because we need 7 years of data for litigation support, even though when I look at the reports, business users don't care about what happened in 2012. Nobody thinks that whatever happened in 2012 is going to prepare us for 2021. Does anybody here on the call think that we could severely analyze anything our business was doing 7 years ago and know what was going to happen next year? No.
Not at all.
Not at all, right? So why do we have these great big data warehouses? It's because we are throwing all our historical data in that. We've All this historical data means that we can't back it up, we can't restore it, we can't manage it, we rebuild the indexing, it takes too long. Dev and other environments are difficult to spin up. If I have a new developer, like I hire Rob says, I want to be your analytics developer. I can't give him a developer environment because the data is too big and it's too expensive and he can't put it on his laptop, right? Cleaning PII and sensitive data is very difficult. Automated tests are very difficult. So that's another weakness. It's very difficult to move large analytic systems up to the cloud. So if you're being mandated or asked to move a giant data warehouse up to the cloud, it can be really expensive. The cloud makes you pay for four things. Every time you spend $1 with the cloud, you are buying one of four things: CPU, memory, network, and disk. Of those four things, CPU is the most expensive. So if you have a great big data warehouse in a SQL server, your queries are anchored to the CPU, and you're going to spend a lot of money on CPU when you run queries. So the cloud is going to punish you for a great big data warehouse. You want to avoid that. You would much rather have a lot of small things than one great big thing. So I show you a picture of a cockpit here because in the cloud, if I have lots of small things and something isn't performing quite right, I've got a knob to turn on the small thing. So if I say, hey, you've got 50 tera in the cloud, but you've only got like 5 gigs in that data mart. Well, a 5 gig data mart, I can move the slider bar from like $50 a month to $500 a month, and no one will notice. But if I have a 50 tera data warehouse and it's in the cloud and it's something slow, one little thing in that giant data warehouse is slow, and I move the slider bar, I'm moving it from 10,000 a month to 20,000 a month. Someone's going to notice that. So we don't want these great big data warehouses up in the cloud because the slider bar, people notice when we move it. But if we have a lot of little things up in the cloud, when we move the slider bar, no one notices. We can slide things around. Lots of little knobs in the cloud make things scalable, and that's what we're going for. Does that make sense so far?
Yep, sounds great.
Okay. So here's some common business complaints about analytic teams. They don't change as quickly as we'd like. They said they'd work for all departments, but it seems like they only work for finance and sales. The data is unreliable. Every time I ask for something new, it takes 6 weeks, and by then the opportunity is passed. The cubes have outdated references to business concepts. I once had a customer that changed the name for student to learner, and they were angry when they had 700 reports that all said student on it, because they decided they wanted to get into business education and they didn't want to insult business customers with student, which I didn't find insulting, but that was their idea. So anyway, they'll say, hey, we don't call these things the same thing anymore, and all these reports and cubes all have bad words in it. Why don't we just update the names of all of these things? Well, when you get back here, this is why we don't update the names, right? It's too hard to update all the names, right? Okay, all right. What the business doesn't understand when they say these complaints is that they're the reason why. They're the cause of these complaints. And the reason why this is happening is because the business is worshiping at the altar of consistency, meaning the business wants all reports to be consistent with each other. For instance, if I say on one report that we run a university and I have 33,000 students at the university, and on another report, we have 34,000 students, both reports are not accurate and invalid and untrustworthy. And the reason why the business thinks that way is because they worship at that altar. They want everything consistent. That need for consistency is our fault, by the way. It's because, let's go back to this slide. I thought I had a different slide in there, but let's go back to the slide for a second. That need for consistency is our fault. When we initially implemented Kimball data warehouses, we would say things like one version of the truth, a place where all your data is clean, a place where everything is consistent. And when we pitched that, we told the business that we would accomplish something that nobody has ever accomplished. What we didn't account for was the fact that the data is accelerating to a severe state, And we have a mountain of data coming from all sorts of different places, and it's impossible to keep all that clean, right? So we need to dial that message back. Now, there is some consistency that's good. Internal consistency is, does this report match what this report is saying? Meaning, do the totals add up to the line items? That consistency is not negotiable. We have to comply with that. There's external consistency. Does this report match every other report, which I think can be negotiated? And historical consistency, which does this report match itself from years past? So like I said, the first one's mandatory, but the second two should not be mandatory because they affect how quickly we can implement new reports. If you go back to the scales here, on one side of the scale, I put consistency, and on the other side, I put speed. Speed represents how long it takes me to make a new report. So if you don't require me to be consistent with all the other reports, I can make a Power BI report in about 4 to 16 hours. I can make just about anything you want in 4 to 16 hours. If you require consistency, that time to build a report maybe will take me weeks, right? 6 weeks maybe. So it's that request for consistency that's affecting that complaint about the system. Every time I ask for something new, it takes 6 weeks, and by then the opportunity is passed. That need for consistency is what is driving that. And that is because we created these great big huge data warehouses that we can't change, and that every time we add to it, we're out of whack with the rest of the reports, right? Okay. I call this the boat ownership of reporting. I've owned several boats because I'm a slow learner. I don't know why I buy them. I should never buy another boat again. Just rent them. But they always say the happiest day of a boat owner's life is the day he buys the boat, and the second happiest is the day he sells it, right? So boats need to be maintained. Anybody who's ever owned a boat will tell you that things break on them all the time. And if we have 700 highly consistent reports, we are going to break a lot of things on our boat, and we're going to need to repair a lot of things. So the best thing that we can do is sell them, get rid of them, delete them, okay? So I'm giving you a lot of complaints, but trust me, I'm going somewhere with this, okay? I promise you I'm going somewhere. We're going to talk more about that topic that I just talked about in just 1 second. So another problem with the formal EDAs that we used to make is that we overloaded them for everything. So we used this system for alerting, for reporting, for data lineage, for data governance. We just overloaded it with everything. And there was another problem with this, and that is that data movement took too long. When people started talking about real-time data analysis, if we tried to make this real-time, no dice. There's no way that I can make some data flow from the source all the way to a Power BI data set or data model any faster than what, every 20 minutes or so? Doesn't feel like real time, right? The business thinks that real time is measured in seconds, not measured in 20 minutes or an hour or 5 hours or 8 hours, right? So they didn't want it. We tried to make this as fast as we possibly could, and it was never fast enough for the business, is my point. Okay, so all that, and let's talk about a traditional data lake. So a data lake, the term was coined by James Dixon from Pentaho in 2010. And I'm going to paraphrase his quote, but basically what he said was, if you think of a data warehouse as a clean, purified bottle of water, a data lake is a place where data lands that is not clean or really fit for consumption, but is still usable for some things. So he was advocating that we collect all of this data into one place, and then from there, we ETL that data into data marts, and likely those data marts would be relational. So that would mean that we would land the data into the data lake using either batch or ETL processes from the original apps that we had, right? Sometimes we stream the data in from like IoT devices or other sources. We throw it into the data lake, and then from there, we hydrate a lot of different data marts that are used for reporting, analytics, data science, and things like that. So this type of data lake was typically called the capture layer, pipelining it into the data lake. The storage layer is the data lake itself. The data lake storage is not relational. It is file-based. I'll talk about that in just 1 second, okay? And then we deliver that using relational data marts into Power BI or Tableau using star schemas. That's what we were doing. So capture, store, and deliver were the 3 stages of a data lake. Now, even though this cylinder in the data lake looks relational, it really is not. It's typically file-based. And I spend a lot of time telling relational DBAs to not be afraid of files. When we used to think about files, we used to think about CSVs and CSV or XML, even worse, right? And those files were brittle, they're fragile, they were slow, they were hard to maintain data integrity. But I'm here to tell you that files are fast. We are not using CSVs when we talk about files. Files are flexible. New data and new columns can be added to it quickly without changing the old data. Files will write data only once through a data structure. Files can be indexed. Files are stored cheaply. So I'm advocating something that the industry has been advocating for a decade, which is don't store your data in relational databases if you can avoid it. And a great place to avoid relational databases are in the staging section and the ODS section of that pipeline that we talked about earlier. If we remove SQL Server from the ODS and instead we use files, it will be fast, it'll be cheap, it'll be easier to maintain, it can have high integrity, and we can even store data that's not really well structured, like PDF resumes or images or things like that can go in the data lake too. So if the whole idea of an analytical system is that data duplication will speed up aggregation and reporting, SQL Server doesn't reward us for duplicating data. The more we duplicate data, the more expensive and fragile it is in a relational store. But in a file-based store, we can duplicate data all the time and spend pennies on the dollar. Nobody will notice if we take 10 tera, duplicate it, put it over, and spend like $100 a month doing that? No one's gonna notice that. But if you take 10 tera on a SQL database and you duplicate it for whatever reason, they're gonna notice. That money, that bill will get, somebody was gonna pay attention to that bill, right? So files allow us to do what analytic systems were intended to do, and that is duplicate data more frequently. Now, if we're not going to use CSVs or XML or JSON files, what files are we going to use? The answer is typically and increasingly Parquet files. So with SQL Server, you know how in SQL Server, we use column store indexing, and column store indexing allowed us to compress, and it shredded the row store into columns so that we could do single pass analytics over it much faster. So that if we wanted to do sums and averages and things like that, and we wanted to do it by store or by employee or by customer, it was really quick, right? That's why we had column store indexing. Parquet files are that same columnar technology with similar compression, but file-based. And traditionally, they've been stored in HDFS, but we can store ours in Azure in ADLS, which is Azure Data Lake Store, which is effectively HDFS for the cloud. It's super fast to pass data over. It has all these features for storing data. It's pennies on the dollar compared to SQL Server and column store indexing, right? And it's splittable and horizontally scalable, which means that our pipelines can run on different servers and use the same storage system and not step on each other. When we use SQL Server and we have a bunch of different pipelines bringing data in, SQL, when it has a lot of batch processing, starts getting IO bound pretty quick and log bound. It starts overloading the log over and over again. If we remove SQL from that stuff and instead use file-based, we can load it, scale it, split it, and we won't notice any IO contention. And maybe not any is a strong word, but much lower IO contention. Okay. So remember in the cloud, small things are scalable and changeable. So remember I told you about all those little knobs? We want lots of small things, lots of files coming in. We don't want one big large file, we want lots of small files coming in, okay? And so right away, if you want to implement a data lake right away, all you have to do is remove SQL Server from staging, remove SQL Server from ODS, and replace it with Parquet files and some type of pipelining that will write to Parquet. You know an easy way to do that? In Azure Data Factory, there's a copy table function that will write any table you want out to Parquet if you want. So we've got easy ways to build Parquet files that don't require a lot of work. You know what? Let me correct myself. I'm trying to avoid using the word easy because I realize that when I do that, if it's not easy for you, you'll stop progressing and you'll stop putting work in. So I don't want you to feel bad about yourself if I describe something as easy in order to get you to do it, and you find that it's not that easy. Let's just say that if it's not as, it might not be as difficult as you imagine it would be. It might still be challenging, but it's worth it, and we should do it because that's the way we're building data warehouses now, okay? And enterprise data architectures now. All right. So here's an example of one modern data architecture, not quite as modern as I'd like. I'm going to get to a punchline here in a second where I'll show you what we'd really like to be building. But you grab the source, you ETL it into long-term storage. Maybe that's Azure Blob Storage or Azure Data Lake Store, ADLS, like I mentioned. And then from there, we do some type of processing. So that data lake would be our storage layer, right? And then we would build some processing to perhaps build relational data stores, or throw it into Azure Analysis Services or Azure Storage. And we would build our serving layer. And then off of our serving layer, we would use Excel or Power BI or web applications to consume the data off the serving layer, or ML, ML tools to do it. Okay. So back to the list. Remember when we said that we were overloading the data warehouse with alerting and reporting and history and archiving data and all that nonsense that made it slow and cumbersome and tightly coupled? What we should do instead is build separate systems for each one of these things. We should not build one system for all of these things. So do you remember earlier when I said the business worships at the altar of consistency, and the business wants things consistent? What we should consider doing is build a consistent data mart. Maybe we call it the board of directors data mart, right? Maybe we call it the executive data mart. That executive data mart is where consistent things happen. So we would grab data from the source, throw it into the data lake, right? Then from the data lake, we would build some type of pipelining, and we would create our executive data mart. Maybe we put it in SQL, maybe we put it in Azure Data Lake Store, maybe we put it in Azure Analysis Services, or maybe we put it directly into a Power BI data model. But whatever we do, we should have one place where executives go to get the truth that's decoupled from alerting, decoupled from managers getting their reports, decoupled from everything. And there we say, this is where you go for consistent data. We avoid saying one version of the truth. All data will be cleaned. All data will be consistent. We try to keep the total number of reports in our executive data mart to less than 50, because that is how we will keep our agility. That is how we will be able to make changes quickly so that we can respond to them quickly, because we want new report authoring to take lower and lower amounts of time, not higher and higher amounts of time. But we need to remind them that when they make us make a new report, let's say we make our 51st report, we have to make sure that that report is consistent with the other 50 reports. And no amount of creating an ideal platform will solve this for us. Somebody's gonna have to go in and look at all 50 of those reports. They have to test them. We shouldn't release anything to an executive data mart without testing everything that's in it, because they might be using that to report it to Wall Street or report it to the board of directors. And we need to make sure that it's accurate. I've never seen a CEO angrier than when a board of directors calls them out on bad data. They really don't like it. Basically, the board of directors is accusing them of lying. So we need to make sure that never happens. All right. So sometimes what we do is we create a logo, like this is the Ford Motor Company consistent report, right? We create a logo. If you see that logo on a report, that tells you you're getting it out of the consistent report. That also means that we don't overload alerting with the executive data mart, right? So we pitch to the business, hey, here's our alerting layer. And we tell them, we throw the data into ADLS, right, for storage. And then we use some type of streaming or data processing or something else that we're doing in order to create an alerting dashboard or an alerting web application to tell you things like fraud, or you're running out of stock, or you know, half of your employees didn't show up to work today or something like that, right? All that should be done in alerting, and it should be separate from the slower path that we were using for consistent reporting. So You pitch it to the business. You say, hey, we're going to use file-based for staging and ODS. We're going to use relational for the data marts, right? And this will be on the left side, flexible and inconsistent reporting, and on the right side, cleaner, but maybe more tightly coupled. And it might take us longer to build things on the right side of the slide. So now let's talk about a properly designed data lake. In data lake vernacular, what we used to call staging, ODS, and star schemas, we now call bronze, silver, and gold. Now, I don't know why the name changed, but the name changed. So what that means is if a data lake is nothing but files, we need to govern those files. So where data lakes have often failed is they've taken James Dixon literally and said, oh, I was cleaning data in a star schema before, and now I don't have to clean the data anymore. So they just start dumping data willy-nilly everywhere in all sorts of folders, and there's no governance, there's no cleaning, it's just mayhem in the Wild West everywhere. Please don't do that. The reason why I started this lecture talking about star schemas and the importance of them is because clean data is important. Governance is important. Clean data inside a data lake is important. So yes, we're going to use folders, but we're not going to let it be a chaotic Wild West. Instead, what we're going to do is we're going to move things and stage it in bronze. We're going to clean it lightly and create a place where we can do joins and things like that in brokerage in silver. And then we're going to build star schemas in gold. And those are just going to be folders in ADLS. We just create the bronze folder, the silver folder, and the gold folder. That's it. Okay. We can organize the silver section maybe by source or by security. In the data lake, we can do all of our historical snapshotting and temporal data. And let's just talk about that for a second. So how many of you have ever said, a business holder has said, we end the year in September, and I want to know what our data mart looked like in September of last year. And you're like, oh my gosh, I can't do that. That's 20 gigs or 20 tera of data. Like, that's too much. I can't just make a copy of that for you for every year you want, right? But in a file-based data lake, you can do that. You do have the ability to do that. So what you get the ability to do is you get to say, it's all files, right? And they say, when the year closes, copy that for me so that I know what September 2019 looked like. You're like, sure, that's like $100. I can do that. You take all that gold folder, you copy over to gold 2019, you put that business user on it, and you say, have a ball. That's your place to go look. It's we're not going to let that type of snapshotting affect the rest of the business. But now you have a place to put Excel or Power BI on, and you can look at it. Okay. We can do that with temporal data, things like that. Like I said, when it's file-based, we get to duplicate and copy. This is what we get to do. All right. Now, a lot of you were looking at files and you're like, wait a minute, I know Transact SQL. I know how to work with SQL. Using Parquet or some type of file-based store is too severe. It's too steep a learning curve. And I'm here to tell you, not that it's easy, but that it's possible. And it's possible because we have something called data virtualization, which in SQL we call Base. We call it Spark SQL or Hive. Power BI does data virtualization. And that is when you have these Parquet files, you can implement a metadata layer over it where you assign structure to it. So that might seem a little bit confusing. Let me simplify. How many of you that know SQL can read what these statements are doing? Let's see, create table rectangles. How about create table boxes? Width int, length int, height int. Could you write that? Have you written that before? You've definitely written that before, right? But listen, use Parquet option and look what's happening here. If you look all the way to the bottom, create table, my table, name, string, age, int, hair color, string, use Hive, and look, this is the format and the location for this. Okay, what's happening? Let's see if I've got another example of this. Maybe those aren't the best examples. Let me see if I can find a good one for you. Okay, this is a good one. Okay, do you see this? Create database, create table. This is Polybase. Create table employees, right? And what they do in Polybase, and it just cuts it off at the end. Let's see if I can find a better example. They specify the file at the end of the create table statement. So this is not that great. I'm not seeing a really good example. Here's another one. Create table, schema, and then here's the location. And the location is just an Azure Blob Storage container. Okay, so what's the point of this? What I'm trying to show you is that we can, maybe you guys didn't see that because I was using the wrong monitor. Let's there, here it is. So there, create external table. Look, the name, the data type, the name of the data type, and then the location right here. Do you see that? Okay. What that means is you get to build the schema of your table independent of the data structure in the files. So what that effectively means is that we can have hundreds of files and we can create a table structure over those files, and it will be queryable. You can query that using data virtualization. In Spark, it looks like this. So like select a couple columns from this, from table is really a file underneath. And guess what it is in Polybase? In Polybase, it's just transact SQL. You're in SQL Server Management Studio, or you're in Azure Data Studio, and you're just writing queries against files using SQL, using data virtualization. That's all possible. Does this look complicated? Could you guys write this if you had to?
Oh yeah.
Yes, you could. Yes. So let's talk about some other things real quick. So yes, we still make star schemas. Yes, we still build cubes. We might use SQL Server. Pardon me, I thought I closed Slack. We might use SQL Server for our gold level area for our star schema, but we don't have to. We can use a file-based system, create tables over the file-based system and interact and query with them and bring that data in Power BI, okay? We also have a different thing that we can do. Let me show you that real quick. I'm gonna bring up, I've got a little bit of time left and I wanna show you one little quick diagram real quick. Got it here queued up. Sorry about that. Let me look real quick at this. Where did I put it? Sorry about this. I know this is boring, but I had something saved for you guys. You know what I'm gonna have to do is I'm just gonna draw it on the fly real quick. So let me use PowerPoint and draw it. Okay, here I am. So if you know that you've got data virtualization, what that means is we can have Azure Synapse here. Have you guys heard of Azure Synapse? And we can use data virtualization there. And then underneath, we can put all of these files. And then in addition to that, we can have SQL-based data marts. So this is a data mart. Okay. And down here, let's just say this is our gold files, right? So remember we talked about having gold, which was the star schema, silver, which was the ODS, and bronze, which was the raw data, right? That was landing and staging, right? What data virtualization in Synapse allows us to do is it allows us to, query that query that, and query this, all with, here's the punchline. Okay, so what we can do with Synapse is we can put data in a SQL relational data mart. Remember when we talked about the executive data mart? And I can put data from an IoT application in my Silver files. And if one person needs a report that pulls data from the executive data mart, but it also pulls data from that IoT data that's landing in bronze and moving to silver, I can create one query, one select statement that pulls data from all of those places without the user knowing about it. That's what Synapse is offering you. That's all of that time to get you to this point, which is we can do modern data architecture and tie our traditional EDAs. Maybe we have a data warehouse that we really love that we need to pare down and put into the cloud, along with the raw data that we're building with new applications, and tie them all together for analytics, for data science, for reporting, and for Power BI. That is possible. We can do that. So finally, the next question I want to answer is, what's Power BI's role in all this? Well, this could be a star schema, right? So let's just throw that in here real quick.
Excuse me 1 second, Ike, before you move on too far.
Yeah.
I've got a couple of questions here that I think now would be a good time to address.
Sure.
Can you create Spark SQL views to contain business logic over external tables, like for ETL?
I prefer you didn't. I prefer you kept that separate out of the views, but yes, you can do that.
Okay.
Yeah.
And then what about views of external tables? And do you have any idea what performance or something like that would look like?
The answer to that is complicated, and I'm under NDA, but I can tell you that the team is aware of some constraints around performance and are actively making it much, much better. So yeah, I think that's a fair thing to say. And I think if you look at what other products are doing, like Athena or Presto or even Snowflake, you would get an idea of what the team is considering. Yep, I think that's fair. So where do Power BI data sets fit into all this? In an ideal world, you will keep the star schema going either file-based or SQL-based, right? And you will choose your fact table granularity landing there, and you will use Power BI DAX to create your measures and metrics and aggregations, and not store too many aggregation tables if you can avoid it. If you do that, you will find that Power BI data sets will be easier to maintain, and that these star schemas will be more useful to other people that are not Power BI users. And you'll get very fast Power BI data sets that aren't cumbersome to build reporting off of. Like I said, what you don't want to do is just bring in 300 tables in a Power BI. Nobody wants that. You want to stay with star schemas wherever you can. And that's it, you guys. That's my presentation. Hopefully that clarified where we are with data modeling and where we're headed. Let me know if you have any questions. You can reach out to me. If you go to ikeellis.com, you can find my Twitter and my YouTube channel and other things. I'm going to be recording a version of this very soon and putting it on YouTube if you want to see it again or share it with other people.
This is great. Thanks a lot. We've got a couple of questions still out there if you've got a couple of minutes.
Sure.
All right. The first one, and I'm not sure when this would be relevant. So, Greg, if I need some more context here, just pipe it into the chat. But how do you handle referential integrity, post checks, or constraints?
Well, in an analytics system, we typically do that in the pipelines themselves, and we try to avoid doing that in any data structures, because those constraints will actually constrain your ability to load data quickly. So the more constraints you have in the database, the slower the data will be, and the more irritated the business users can be if they were expecting more current data. And the more constraints you have, there will be a stopping point to how much data you can load. But the fewer constraints you have, the faster you can load data and get it in there for some kind of use. And then if there's any business logic that absolutely has to be maintained, let's say in the executive data mart, in that highly consistent area, we would do that in the pipeline itself.
Okay. The next question is, oh, Greg says that answers it. Thank you. Great, perfect. The next question from is, do you recommend loading Azure analysis services from files? And if so, what type of files?
I don't have a recommendation on how to load it. I think it would depend, but I would typically load it from a relational data store. And if I were using a file-based system, I would use Parquet and Spark if I could get away with it. Power BI has a Spark connector that will read data directly from Parquet files.
That's awesome. I don't see any more questions. We've got a couple more minutes. If anybody has any more questions, go ahead and throw them out there.
I know I spoke fast. I had an hour, so I wanted to get everything I wanted to say out in the time I had.
Here we go. Can you recommend good resources, websites, books, or otherwise that covers all this step by step?
That's a good question, and that's kind of why I was giving this presentation, because I went on Pluralsight and I didn't see anything. You know who I saw in the audience? I just was glancing at the audience list to see who showed up, and Melissa Coates was here. I think she left the session already, but she speaks on this topic frequently. In fact, some of the images that I've used in the past, I've used based on Melissa's work. So you might take a look at her sessions. She talks about it a lot. She's got one session where she goes in detail about Lambda architectures. I described Lambda to you without telling you that's what it was. But when you separate alerting from batch processing, that's a Lambda architecture. So you can look at that. That's
excellent. Thank you very much. The next question is this being recorded? Yes, it is being recorded, and I'll probably get it posted to the Data Architecture Group's YouTube page or the past YouTube page either this evening or first thing tomorrow morning.
Actually, can we edit it before you post it? I got one.
Sure.
All right, thanks.
Yeah, no problem. Just let me know.
Cool.
And I think that's it. Ike, thank you very much. This was great. I really, really appreciate it. This is wonderful.
Yeah, thank you. Thanks for having me.
Thank you.
All right, thanks, guys.
All right. Well, thanks a lot. Thanks, everybody, for joining us, and we will talk to you next month. And yeah, we'll get this edited and uploaded to YouTube as soon as possible, and I'll send out an email to let everybody know. Thanks again.
Thanks, guys.